Hello, ladies and gentlemen, and welcome back. I'm your Earth Science teacher, Mr. Stano, and we're going to continue with our season talk coming right into the summer solstice. Remember, in the last screencast, we mentioned that the predominant reasons for the seasons has to do with Earth's tilt and its revolution around the sun. Now, the information that's coming up now is very specific information to the summer solstice, winter solstice, and the autumnal and vernal equinoxes for us in New York State. So they're very specific to that. So this information here is pretty much for us in New York State. It will vary around the United States, but here this is what we're looking at. Remember, in our summer solstice for the United States, the northern hemisphere is tilted towards the sun. So our sun is over here, and notice the northern hemisphere is tilted towards. When it's tilted towards, what happens is the sun's rays come in, and notice that they're going to hit in our northern hemisphere. That energy is now being predominantly put out, or the higher intensity of insolation is in the northern hemisphere, which is going to increase our temperatures. June 21st is the start of our summer solstice. It's our longest day of the year, basically meaning all days have 24 hours, but we have increased daylight hours. Okay, Earth's axis is tilted towards the sun, or the northern hemisphere is tilted towards the sun. The sun has the longest path in the sky. Remember, a couple of screencasts ago, we talked about that celestial sphere, how all objects in the sky appear on it. If we look down here, this is our celestial sphere. Notice that the sun rises for the most part in the east. It's up to its highest point, which would be noon, and then sets somewhere in the west. This path is longer in the summer. It actually has a bigger path. Notice the sun rises not directly in the east, not in the north, but northeast, and sets. Here's west, here's north, somewhere in between, which would be northwest. If you would like to get this diagram down, I would. It's a good little diagram of the celestial sphere. During the sun, we have 15 hours of daylight, 9 hours of darkness. That contributes to that longer day. Sun rises in the northeast, like I explained, sets in the northwest. And the sun's direct rays, important right here, hit the Tropic of Cancer, or 23.5 degrees north. This map right here, we have our equator, which most people know, 0 degrees. Tropic of Cancer, 23.5 degrees north. Need to memorize it. Moving northward, even more, 66.5 degrees north is our Arctic Circle. And then the North Pole, 90 degrees north. These numbers you need to memorize. They're actually in your reference table also, so you either need to know, they're in your reference table, I believe it's pages 3 and 4, or just memorize them. If we move south, they're basically the same exact numbers, 23.5 degrees south, Tropic of Capricorn. Go south even more. We have our Antarctic Circle, 66.5 degrees south. Finally, the South Pole, 90 degrees south. These numbers right here are important. It's going to really depend. Basically, this is the northernmost altitude that the sun's direct rays are going to hit in, the southernmost altitude where the sun's direct rays are going to come in, and then you'll see there's special scenarios with 66.5 degrees north and south. When we look at here, we're looking at a space view of the Earth. These are sun's rays. Notice we have our equator right here, and that the sun's rays aren't hitting directly here. They're actually hitting directly right here at 23.5 degrees north. If we draw a line tangent to that location, notice the angle is 90 degrees. That's our most intense insolation. Also look at the shadow itself. Notice the shadow runs completely north to south, but the shadow right here, if you look, does not hit anywhere above 66.5 degrees north to 90 degrees north. As the Earth rotates, these areas never go into and out of the shadow. Well, if they never go into or out of the shadow, that means they have 24 hours of sunlight. If you look at it right here, notice as we rotate, these areas never go into and out of the shadow, and they have 24 hours sunlight. So where that shadow is plays a huge role with the amount of sunlight that we receive. 90 degrees, notice that this path from here to here is 13 and a half hours of daylight. It's going to be a longer path than this one right here. This one, same thing, longer path. These longer paths are going to contribute to more hours of daylight. Our winter solstice, everything is the exact opposite, so it's pretty easy to do. Winter solstice, shortest day of the year, we have less sunlight. Less hours of sunlight. Earth's axis is tilted away from the sun. Northern hemisphere away from the sun. The sun has the shortest path in the sky, and we can see that here. Goes up, rises to noon, and sets. Notice that it rises southeast and sets southwest. Here's our points right here. Good little diagram to copy. 9 hours of daylight, 15 hours of darkness. Reverse of the summer. And the sun rises in the southeast, sets in the southwest, like we said. And the sun's direct rays hit that southern hemisphere at the Tropic of Capricorn. So our winter is the exact opposite of our summer. And then we have our equinoxes. The equinoxes are relatively easy. Whether it's the spring or the vernal equinox, makes no difference for the most part. March 21st, September 23rd, those are the actual dates of the equinoxes. Equinox, we see the word equal, noxus, night. So we have equal hours of day and night. 12 hours day, 12 hours of night. Sun rises directly in the east, sets exactly in the west. Probably the easiest to remember. And the sun's direct rays are going to be hitting the equator right here. You can see our tangent line drawn. So we have a 90-degree angle. Looking at and over, basically from space towards the Earth, we can remember, look at the shadow. Probably our most important thing. Shadow runs directly through the northern and southern pole. That's how we know we're in the equinox. We look at it from overhead. Notice it runs right through the poles. It'd be no different if we looked at the southern view of the planet. Sun's direct rays hitting perpendicular right at the equator, or 0 degrees. That's how we know it's the equinox. It's not tilted towards nor away from the sun. Good diagrams to get down also. And I'm going to stop here before I go into the noon sun and a little bit more into celestial sphere. Hope you enjoyed it. The diagrams, like I said, are very important with this. Make sure you have all the information. And that's about it. Have a good night. Take care.